Hello everyone, welcome to today's live broadcast. The future of liquid handling automation has arrived. I'm Judy O'Rourke of LabRoots and I'll be your moderator for today's event. Today's webcast is presented by LabRoots.com, the leading social media site for science professionals, and sponsored by Beckman Coulter Life Sciences. Beckman Coulter Life Sciences develops, manufactures, and markets products that simplify, automate, and innovate complex biomedical testing. More than 275,000 Beckman Coulter systems operate in both diagnostics and life sciences laboratories on 7 continents. For over 75 years, our products have been making a difference in people's lives by improving the productivity of medical professionals and scientists, supplying critical information for improving patient health, and delivering trusted solutions for research and discovery. To learn more about Beckman Coulter Life Sciences, please visit www.beckman.com. Before we start, there are a few instructions. We want to hear from you during this interactive broadcast, so please ask questions or leave us a comment. Answer is welcome too. And you can do this by hitting the green Q&A button at the lower left of the presentation window and typing in your comments and questions. We'll try to get to as many as we can, and we'll follow up if we don't have time today. Want a better look? You can enlarge the slide window by clicking on the screen icon in the lower right-hand corner of the slide window. If you can't hear or see this presentation properly, let us know by clicking on the support button on the top right or use the Q&A button. We'll make sure we try to resolve any issues. Now let's get right to today's presenters. We are proud to welcome Raj Kapadia, Bob Lund, and Tim Sherrill. Raj Kapadia leads the Beckman Coulter Life Sciences automation team with responsibilities for both product management and market development functions. He joined Beckman Coulter from Illumina, where as head of the Clinical Core Products Group, he drove efforts to move next-generation sequencing into the clinic. Prior to Illumina, Raj was the director of the oncology and genetics franchises at Abbott Laboratories, which held a #1 share in molecular diagnostics. Earlier in his career, Raj held a number of roles of increasing responsibilities in research and development at Ford Motor Company and was a management consultant at PricewaterhouseCoopers. Bob Lund is a senior product manager for automation at Beckman Coulter Life Sciences, who is associated with the Life Science Automation and Genomics Business Unit. Bob has been involved in the development of laboratory automation systems for nearly 30 years, including being a core team member responsible for product planning and management for the development of the new Biomek iSeries Automated Workstations and the eventual commercialization of the product. His scope of responsibility also extends to Beckman Coulter Life Sciences thermoplastics operations in the production of certified Biomek pipette tips and centrifugation tubes and bottles. Tim Sherrill is a staff systems engineer in the Integrated Solutions Group of Beckman Coulter Life Sciences. He received a degree in computer science from the Rose-Hulman Institute of Technology. Tim has spent his career with Beckman Coulter in the areas of software research and development, custom engineering services, field project management, and life science automation. His projects have focused in the areas of automated data processing and last year a new version of Beckman Coulter's data management product, DART. I will now hand it over to Raj Kapadia.
Great, thank you. Let me start off by welcoming you all to our iSeries platform launch webinar and thanking you for taking the time to join us. We here at Beckman Coulter are excited to introduce you to our new iSeries portfolio, which will allow us to deliver new solutions for genomics, drug discovery, academic, and applied workflows. Today, we will review in detail our iSeries platform, associated consumables, and software suite. Before we dive in, here are some required disclaimers about today's presentation. While we are very excited about the iSeries, these new products represent only the first step in our recommitment to innovation and to you, our customers and partners. This refocus at Beckman Coulter has been enabled by our parent company, Danaher, and its Danaher Business System. Embedded in the Danaher Business System is a focus on customers and a drive for continuous improvement. These two ingredients give us the confidence to commit to you that we will be your partners in driving greater efficiencies, cost savings, and more robust solutions that allow you to deliver repeatable, reliable results. Our customer-focused approach drove us to guide our iSeries development by the input we received directly from you. The input that we got really came from a diverse mix of customers in terms of multiple markets, geographies, lab types, and stakeholders. included a mix of phone conversations, learning from our years of partnership with you, and surveys. We digested all those insights into 5 key bullets that guided our iSeries development efforts. The first being that partners that continuously deliver innovation is what you told us you wanted in a partner that provides key products for your labs. Intuitive systems designed with your applications in mind, technology that drives efficiency into your workflows, flexible systems that are adaptable for your changing priorities, and of course, the trusted and reliability and knowledgeable support within the products you buy. We are happy to say we have the new iSeries, which is designed for your evolving workflow priorities. Really, from that input, we have gained the insights of what really set the foundations of this product. Simplicity that enables focus on science, efficiency to deliver productivity gains, adaptability to extend scale and reach, and reliability and support to reduce downtime. We're very excited to share with you the details of how we will and how this product delivers on many of these key messages. Now, in addition to the Biomek iSeries, we're really enabling a whole new set of workflows. We are proactively developing automated methods for applications that are most relevant to our customers and our partners. Beyond developing applications in our labs, we established partnerships, internal and external, to Danaher to provide applications that our customers need, ensuring our systems can deliver the expected results. It really is this solutions-based focus that allows us to really partner with you, again, our customers and our partners, for the years to come. With that, I'll hand it over to Bob to cover the details of the new iSeries Automated Workstations.
Thanks, Raj. Yeah, so I just want to go through a few of the highlights of the new Biomek iSeries platform itself, and as Raj has just commented on the particular attributes that we focused on in terms of high-level goals for the platform, that being simplicity, efficiency, adaptability, and reliability and support. Under simplicity, we're going to be looking at a little bit further detail here, some multicolor status light bars, illumination on the deck, and of course our Biomek software, as many of you on the line are probably used to from all the years we've been in the business. Efficiency, we've improved on the deck capacity itself of the instruments, new gripper design that takes advantage of that larger capacity deck, and a large volume 1 mil multi-channel head with selective tip pipetting that's native to the software, as well as integrated data management. On the adaptability side, we have a grid-based deck, which allows you to configure the deck in numerous ways and framing of that deck. We continue to use what we call our automated labware positioners, or ALPs, to provide additional process functionalities like heating, shaking, cooling functions. And then we also have designed a platform with device integration, so peripheral device integrations like readers, washers, incubators, storage devices, this type of thing. Much better access to this instrument than previous versions that we've had. And then from a reliability standpoint, we've actually added in a deck observation system we'll talk about in a bit here. We included what we call Pro Service, remote service option that we've, so to speak, inherited or are taking advantage of from our diagnostic company here at Beckman Coulter, and then, of course, our user training and application support. So the Biomek iSeries is available in 2 deck sizes or basic configurations. We call the smaller one the Biomek i5, and the larger one on the right, the Biomek i7. These 2 versions shown here are ones with enclosure. The systems come with enclosure or without enclosure. In the Biomek i5, these are single arm platforms, so you would either have a span 8 arm or a multi-channel arm. On the Biomek i7, there's both single and dual arm systems. So on the single, again, we've got a single arm span 8. We have a multi-channel arm, and then we also go to the 2 arm systems, which is either a dual multi-channel or a hybrid version, which is a multi-channel and a span A. Looking again at the simplicity, so you can focus more on science, the instrument status light bars show the system status. You can see in the pictures there on the left, the top one there with the green light bar is one that actually, with the enclosure, actually goes all the way around the instrument, so 360-degree viewing. Some of that input from our voice of customer that Raj had referred to said that our customers wanted to be able to see from across the lab at any angle how the instrument was actually running or if it needed attention. So the status light actually goes 360 degrees around the instrument in the enclosed version. In the unenclosed version, or without the door in the top, we still have a large light bar on the front of the instrument, which can be seen from multiple angles from the fronts and sides of the instrument. We've also included illumination, an LED strip along the x-axis of the instrument. It's actually it contains the x-axis motion control, and underneath that, that I-beam there that you might see there in the top left picture, it's a little bit brighter band. That's where the LED strip is, and it allows you to view the deck better and easier if you want to look to see what's happening. There's also a switch on the right-hand tower or side of the instrument that you can turn the light off if you have light-sensitive assays, for example. And then we continue to use our Biomek software. We debated about this for a while in terms of totally revamping our software, but the feedback from, again, our customers was that they really enjoyed the Biomek software and found it easy to use and very flexible. So we decided to continue on with the base versions of Biomek software. It is Win 10 compatible, and we've also added in a few other features. We've got a new user interface that incorporates a ribbon. We've also included selective tip pipetting. That's actually native to the software. We've also included volume splitting, so anytime that you're looking to transfer a sample volume that's larger than the pipette tip that's being used, rather than entering two separate method steps in terms of splitting that volume manually, you just have to enter the larger volume that you want transferred, and the software calculates how many trips back to the source and to the destination that it needs to do. We've also enhanced our labware library search function. Makes it easier. It's based on well types, manufacturers, and well densities. And then lastly, we've incorporated independent probe calibration for our span 8 system, which significantly improves the ability to hit better inaccuracy or better accuracy values for your pipetting. To improve on efficiency and deliver higher productivity, we've incorporated a large deck capacity, and really we're looking at over twice the amount of multi-titer or microtiter plate positions on the decks versus our current like a Biomek NX or FX version. So on the i7 series, we actually have 45 microtiter plate positions. On the i5, we have 25. So that's up from 12 on for example, on an NX, and up from 20 on a FX. The rotating gripper actually has some, we call that high offset gripper fingers that straddles over higher labware, so you can still pick up adjacent shorter labware on either side. And this again allows us to make better use of the higher capacity deck without having to sacrifice positions to the right or left of the target plate that you're after. We now also have a large volume, or actually a 1200 microliter multi-channel head that's proving out to be much faster in terms of sample transfers. So instead of making multiple trips, say with a P200 tip, going say 4 times or 5 times back to the source and then going to destination, You can now transfer a full 1 milliliter with an additional 200 microliters with a blowout in one trip. We also are seeing that the ability to mix wells, for example, with bead mixtures in a genomic extraction procedure is much more efficient with the 1 mil tips, because you can aspirate the full 1 mil in, for example, a 1 mil or 2 mil deep well plate. I mentioned the selective tip pipetting, which now is native in the software, so it's no longer necessary to order a selective tip software as a custom product or as a separate plug-in product for Biomek software. It is now native to the Biomek software. And then individual probe calibration, where on span 8, you can actually calibrate each of the 8 probes to improve accuracy and precision. The new platform is very adaptable. We have the grid-based deck, which you can actually kind of what I would call do islands of functionality, so you can group your, let's just say, various process elements like orbital shakers or shaking Peltier devices all to one side. You can put all your reservoirs, for example, in a grouping or island on the deck. Makes it very flexible to kind of set it up the way you as a user would most like and makes most sense to the workflows that you're automating. We have 4D integration capabilities, so the wide open spaces on the left, right, and even the rear of the instrument are wide open for additional integrations. And also the deck plates themselves, which you can kind of see there in the upper left picture, those are removable, so we can actually put devices down below deck and then push plates up and down between the work surface itself and the devices that are below deck. And then again, just more on the device integrations themselves. You can see on the lower left picture there, we have a number of devices. There's a Beckman Coulter Cytoflex flow cytometer that's directly integrated to the iSeries instrument there. We, in many cases, can do direct integrations, which gets rid of the need to have a conveyor or a shuttle that shuttles the plates off deck, and then perhaps needing a pick-and-place robot to move that plate into the device. We can now do many of them directly and to the iSeries and use the offset grippers to access that device. Saves on footprint and, of course, cost, as well as throughput time in terms of not having to pick-and-place plates. In the back there, you can also see there's a centrifuge, an automated centrifuge in the back. So again, rather than having off deck, a number of devices are there. Washers also can be there, readers, for example. So there's a reader, there's a molecular devices i3X reader there in the middle picture. And on the far right, there's the thermal ATC thermal cycler, which sits right on the deck of the instrument. In addition, we still have room to expand the systems depending on various application workflows. So here it just shows an example of, it actually happens to be an i7 instrument that's enclosed. So you see the door on the front, the halo up on top, which is the blue status light we had talked about earlier. We can put HEPA filtration up on top. This device itself happens to have a Cytomat incubator off to the right. It's based on a cellular application. And then on the left, you see a kind of a side extension or module. The side integration enclosure itself is of the same industrial design as the iSeries instruments. And then within that, there's actually a molecular devices i3X plate reader. All of that is sitting on, the iSeries itself is sitting on what we call a mobile workstation, which has wheels and the doors in the front for storage and routing of cabling. And you can also include trash underneath there. But then also, because of the width of the system, we also have specially designed tables that also attach to the mobile workstation itself to get the necessary footprint needed for this particular design. Labware feeders are another product that fits into the mobile workstations, and again, feed plates and or tip boxes up from underneath the instrument to the deck itself. Trusted reliability and support to reduce downtime was actually one of the biggest focuses for us, wanting to keep instruments up and running as long as we can. So one of those just happened to be the enclosure design that you've seen here on a number of the slides. The enclosure, of course, protects the workspace on the inside from particularly dust, but then if it's more than dust, then either HEPA filtration being positive or negative is used, can be done, or simply hooking up to a external HVAC systems with just ducting. We've also incorporated what we call a deck observation system, which is essentially two wide-angle cameras. They're onboard cameras. They happen to fit into the left and the right towers, as we call them, which is the right and the left front sides there as you look at the instrument from the front. These cameras are actually always capturing video or taking the video, so you can actually do remote viewing. You don't have to be in front of the system. Our customers had made a number of comments about that they would like to know, again, what the instrument status is while they're running a method, but not necessarily either have to be in front of the instrument or even within the lab. So we have even our own applications folks who aren't necessarily in the lab at the time they're running a method, but back at their desk working, can view the instrument status through the cameras at their desk. If an error should occur on the instrument, we actually capture 30 seconds of video before the error and 30 seconds after the error. And this can be pulled up either by the user or by a service person to try to figure out why the error occurred, and they can actually look at the video. In our own experiences here during the development, it was interesting. We were asked to evaluate a prototype thermocycling unit for genomics, and we were doing so, and when we came back and the instrument was stopped and we couldn't figure out why, but yet there was a plate that was laying on the floor in the aisle, and going back and looking at the video that was captured, we could actually view that the plate was ejected by the thermocycler, and it broke the light curtain which we have on the front of the instrument, stopped the instrument, and therefore notified us that it needed attention. So that video was of particular use because we were able to share that with the thermocycler manufacturer, and they were able to make a slight design change to their instrument, and now it works fine. And again, it was based on us being able to capture the error video. Along with that, we have Pro Service Remote Management, which is a tool used by Beckman Coulter Diagnostics. We're simply using their architecture and structure that they have in place. This is optional. It's up to the discretion of the customer. But what it does provide is remote desktop sharing, viewing, and also file sharing. So in many cases, and what we've seen here already in some of our beta testing, is that it may not be necessary for a service person to make a call to a customer site. They can actually troubleshoot the problem by looking at various log files, and for example, even the video, if that so happened to apply, remotely without having to go to the customer site themselves. Or it will also allow them to take a look before going to the customer site and determine what they may need in terms of tools or accessories that they need to have once they do arrive on site, and make the downtime much shorter. And we've also introduced a number of different customer training programs, including some e-learning programs online in terms of running Biomecs and just software, and also liquid handling in general. So we've enhanced our training program here at Beckman Coulter Life Sciences, as well as our application support, whether that's application support internally and or out in the field itself. With that, I'll turn it over to Tim Sherrill.
Welcome. Today I would like to talk through the software solutions on the iSeries platform. As Beckman Coulter approaches automation in your laboratory, we want to partner with you to understand the approach that you have and to make sure that we position tools that are specifically suited to the types of tasks and the workflow that you have as a daily routine. And that begins by first understanding the problem, being able to tackle that problem with an appropriate match of hardware and software solutions. At that point, we then need to layer some methods and the capability on top of that instrumentation, combined with any reagents or kit chemistry which is being brought to bear. And then finally make sure that the service and support that should anything be needed in the future, that's there, and that everything that is required would be done quickly. A critical component of all of this is making sure that the software that is positioned with the instrument is able to accomplish all of your workflow needs. Here are the different components of software that Beckman Coulter uses that relate together. As more instrumentation is added to a system, more software components can be brought to bear. This gives us a very flexible approach, enabled to grow with you as your needs change. None of us seem to be doing the same job we did 5 years ago, and I don't think any of us expect to be doing the same job that we're doing now 5 years from now. And so any automation that you have should grow with you as your needs change. As we bring software components together, we can tell that story with you. Here are 4 different components that go with our software tools. The Biomek Method Launcher is targeted to an end user or operator that will be running methods on a daily basis. It's a point-and-click, icon-driven system that guides an operator through setting up the instrument and ensuring a successful run. The Biomek software is an authoring interface with a great degree of flexibility that can be driven through an icon-driven approach for solving workflow problems in the lab. When scheduling is needed and overnight runs or long walk-away time is desired, SAMI-EX is a visual scheduling software that will manage all of the resources on the system. It's an optimizing scheduler that will find issues and resolve constraints before you ever begin. Bringing things together is a data acquisition and reporting tool which tracks data in a run and can manage run, plate, and sample information across multiple methods and even on multiple instruments, and then provide reports out so that you can understand the results that have been collected as part of your method. I'll walk through each of these in turn. The Biomek Method Launcher is a simple point-and-click interface for running and monitoring methods. The goal is to easily allow you to start a method, walk through the deck setup parameters, whether that's collecting labware such as source plates and destination plates, placing tip boxes on deck in appropriate locations, preparing reagents that need to go on deck in the correct concentrations, in the correct location, both within a sample reagent block or placing it on the correct deck position within the Biomek workspace. This prevents errors from an operator inadvertently altering a method or by placing the labware in the wrong location. This happens through an efficient step-by-step set of instructions that sets the deck, avoiding those errors which can result in a missed run. As the method runs through, there's remote monitoring which can maximize your productivity and walk-away time. You can be sure that your samples are being well taken care of, both by viewing method updates through a web browser as well as viewing the tower cameras that Bob mentioned earlier. This also allows you to set up your instrument at the beginning of the day, such as homing your instrument and preparing it for first-time use. as well as displaying data that's generated during the run. All of this works together to give you reliable results in a predictable way. The Biomek software is at the heart of our software system. This controls the instrument using a simple icon-driven method authoring interface. An important feature of the Biomek software is that it validates methods as you're writing them. It ensures that you do not take out more liquid than is available in a well or try to put more liquid into a well than can be contained. It also performs obstacle avoidance and ensures that there are no crashes on the deck. Any data that's driving a method, such as a hit picking script or normalization that needs to be done to get to a target concentration, all the information driving that process can be viewed from within the method or externally. A 3D simulator allows you to test methods and to look at the precise motions that are being done with the tip, with graphical editors that allow you to modify how the tip behaves within the well, such as a pipetting technique editor and a pipetting template editor. Method author can also embed instructions so that any operator can follow these instructions and set the deck properly, again ensuring reliable results. Simple tasks are done in just a few clicks. You can identify the type and location of labware. For a transfer, you can simply select the source, the destination, and tips to be used. Configure the well selection either graphically or driven by a file, and set a volume. The overall software uses a structure similar to Microsoft Office applications for categorizing the different operations you can perform within the software. The add-on DART, the Data Acquisition and Reporting Tool, captures data brought in from different sources, such as from a hit-picking file, a Biomek, responding to an integrated device such as a reader, a limb system, or even manually entered information. Information collected from the system is automatically stored, whether it's from Biomek or SAMI software, without any modification to the method. This happens automatically. When the Biomek software transfers liquid from a source plate to a destination plate, any data associated with that sample, such as a sample ID or an OD value from a reader, is also transferred to the destination, and DART will follow that data along and collect it for the destination plate as well as a source plate. Data can be turned into usable information at runtime for data-driven applications such as hit picking or normalization. And the reporting tools that are provided with DART include a report that can be viewed from the web or an Excel view where further calculations can be performed. The Excel view has a live link back to the original data. So if any new runs are performed using that same method or match the filter that you've provided, that new information can be automatically retrieved into your Excel spreadsheet. This cuts down on copying and pasting and can avoid the use of CSV files completely. The SAMI EX workstation solves the problem of giving you long walk-away time with a higher capacity system. The power of SAMI EX software gives you a drag and drop interface, so there's no programming or SQL Server skills required to define a workflow in SAMI. You have step-by-step validation, which ensures that everything is connected properly. Any logical mistakes are found through review process and are highlighted in the method authoring environment with a useful message. You can address process details prior to running the method and understand the setup using the SAMI RT function. This can allow you to, in simulation, watch the method run, or when running on the actual system, give you live updates. As plates move through the system, you can see where they are in the method, the progress from 0 to 100% per plate, the progress in the overall run, and the upcoming tasks that are available. Access control can be used with the 21 CFR Part 11 supporting tool that allow logins to control which methods users have access to and whether or not they're able to make changes to methods or simply run methods. For precise timing and to ensure that batches of plates are processed within predefined limits, CME-EX includes an optimized planning scheduler that generates schedules prior to the run. Users can pre-validate these methods and be sure that all the timings are correct for your process. If runtime data is important, then data-driven dynamic rescheduling is supported for applications where decisions need to be made at runtime. A good example is in cell culture applications where, based upon the cell density, the next step could be harvesting the cells or another round of incubation to grow more cells. This wraps up our software section, and I'll pass this back to Bob.
Thank you, Tim. So just as we've been presenting here, the Biomek iSeries itself in terms of like hardware as well as the software features, we also view that a very critical part of the system itself is the Biomek pipette tips. And we consider that the Biomek pipette tips, of course, are the most critical point of contact because that's actually what the sample is touching. In this case, Beckman Coulter manufactures Biomek pipette tips, and really they're the only ones approved for use with the Biomek instruments because we verify and validate them on our own instruments. We maintain a number of biocertifications on the pipette tips, that being that they're DNase-free, RNase-free, DNA-free, both human and mouse. We take a look at PCR inhibition assays as well on the DNA, endotoxin-free and trace metals-free. We have a couple special tip variations as well, that being the conductive pipette tips that are used for liquid level sensing using conductance, and also our wide bore tips, which from an application standpoint reduce shear forces in the tips for genomic cleanups, as well as provide better mixing in terms of bead mixtures, magnetic bead mixtures. And then also you're able to pipette much more easily and in some cases faster when transferring very viscous samples, for example, like glycerol stocks. On the Biomek iSeries, we actually have unified our pipette tip design. So now the tips that are used on a multi-channel 96 head are the same ones that can be used with our SPAN 8 platform. So we verify and validate by Beckman Coulter Life Sciences these tips on our instruments. We certainly know what our design tolerances are on the hardware itself and along with the tips. They're fully integrated into the Biomek software, including the color recognition of the tip boxes themselves. We actually manufacture in a controlled manufacturing environment and use premium grade virgin polypropylene. You can see our manufacturing facility off there on the right in a couple pictures. And as I just mentioned, we pull samples to test for biological parameters like the RNase, DNase, DNA, and endotoxin. So with that, I just kind of want to summarize here by saying that for those of us who have been around for a number of years, it's been an interesting journey and quite exciting that we now have our new Biomek iSeries product out. The journey actually started more than 30 years ago with our Biomek 1000 in 1986. That progressed into the 2000. We had our first foray into multi-channel work with the Multimek 96 pipetter, and then again that progressed to the Biomek FX, then eventually NX, and again into further renditions of the Biomek 3000 and 4000 series, but now this year we're launching the i5 and i7 series. Along with that, we've also had the same journey with various robotic arm components in terms of external peripheral device integrations. Many of you may still be familiar with the former Orca arm we had from years ago back in the mid-1990s. Moved into the SA workstations, even made some industrial robotic arm, 6-axis arm integrations or automated workstations. And now today we pretty much are using SCARA robotic arms and or what we call our BERT or BRT robotic pick and place unit. And again, still allows us to do a number of different integrations and of all sizes. So today, just to that point, we start off with the Biomek 4000, which is our low throughput instrument platform, move up into NX, which is our medium throughput, and then as you can see here in the slide, move on to the i5, into the higher throughput arena in the FX, and then the i7 to the extended workstations, which we looked at earlier in the presentation, and again to full laboratory comprehensive Biomek systems. But we believe this is just the beginning. We now have an iSeries platform that's very modular in design, purposely built that way, so we can continue our innovative solutions to meet various application workflows in the future. We are focusing, of course, on our software enhancements based on user workflows, application workflows there as well, and tie that all together with a growing application portfolio, which can, in many instances here for what we already offer today, include reagents, but then also laboratory labware accessories and plasticware, for example. With that, I'd like to turn it over then for some questions and answers.
Excellent presentations. Thanks for bringing that information to us. Before we begin the Q&A session, I want to advise that a poll question will appear on your screen. You may select your answers, then close the poll question by clicking the X in the right corner. And before we get started with all of your questions, here's a quick reminder about how to reach us today. Questions can be sent via the green Q&A button at the lower left of the presentation window. We'll get to as many as we can. And our first question is Biomek series software Windows 10 compatible? Okay, so we will pause for a quick moment. Again, let me remind the audience about the poll question that is appearing on your screen. Before we begin the Q&A, we are presenting you this poll question. Select your answers. Close the poll question by clicking on the X in the right corner when you are done selecting your choice. Okay. So again, I want to thank our presenters for bringing that information to us. And a quick reminder to the audience about how to reach us today with questions. Questions can be sent via the green Q&A button at the lower left of the presentation window. And I see there are many. We'll answer as many as we can. So the first one is Biomek iSeries software Windows 10 compatible?
Yes, the software is designed for Windows 10 and comes with an automation controller as part of the instrument.
Okay. Am I able to transfer a full 1 milliliter of sample or solvent plus use a 20% or 200 microliter blowout volume?
Yeah, so the 1 mil transfer volume is certainly you can do that on the span system, which also can go up to 5 mils. but I think the context of the question is probably with regard to the new 1200 microliter multi-channel head. And the answer is yes. So we have a tip capacity of 1,070 microliters, so essentially all of that volume can be transferred. But if you think of it as simply a 1 milliliter tip, the 1 milliliter can be transferred, but then you have an additional 200 microliters of potential blowout if you would like to use that. We've kind of standardized on the 20% of blowout volume based on manual handheld pipetters.
And an audience member says, I didn't hear whether an instrument without the enclosure has a light curtain. Does it?
So that's actually a great question that I don't think we did cover. So the light curtain is available on both the enclosed versions as well as without enclosures. What's also nice about the enclosed version is even if you have the door, you're able to move the door up and down, so it's a vertical door, without tripping that light curtain. So the light curtain's there, and again, in the case of the open, it's as if anyone has a Biomek FX or NX today, would be similar. So you break that light curtain plane and the instrument will stop. But if you have the enclosed version as well, it's the same response. But it also includes that you can raise and lower the door without tripping the light curtain. So again, you need to trip the plane itself, and the door will not do that. So you can, if you need to get into the instrument or look closely at it, or forget to put the door down when you start the method and want to close the door, you can do so without stopping the method or tripping the light curtain.
What has been done with error recovery in the system with regard to having the robot continue with the method if an error occurs?
Sure. Errors can occur from a variety of different reasons. A simple thing might be that perhaps there was a labware that was placed in the wrong location. Reaching into the area of the Biomek to fix that, the light curtain would break, all of the motors would have their power cut. You could then place the tip box in the correct location. Even if you move the pods out of the way, you can then click the button. The first thing that the instrument will do is to check that the light curtain is clear. It will move the pods back to the original location where they were at the moment that the light curtain was broken, and then continue on with the method. Now, if there's an integrated device, perhaps there's an on-deck integrated thermocycler, and maybe it wasn't plugged in or turned on. So if there's that type of an error, and there's an opportunity to correct that error, turning the device on. The device can then be initialized and either through a retry button on the instrument, and then the run can continue. The Biomek software has a number of different ways to recover from those sorts of errors.
Can an 80 or 90 microliter pipette tip be used on the 1200 microliter head?
Yes, it can. So an 80 microliter or a 90 microliter would be comparable to what some folks may know as a P20 or a P50 type tip. So both of those can be used on a 1200 microliter head because of the same dimensional tolerances.
Can a 1070, 1025 microliter or 1 milliliter pipette tip be used on the 300 microliter head?
So similar to the last question, the answer is yes. So you can put the 1 milliliter pipette tip on a 300 microliter head as well as the ones that were just mentioned, the 80 or 90 microliter. What's nice about that is again, you can transfer all the way up to a 300 microliter volume because that's the head volume. So in the case of even if someone wanted to do let's say a 250 microliter transfer with a barrier in the tip, but also have the 20% additional blowout, you would simply use a 1 milliliter tip and on the 300 microliter head, provide a transfer volume of 250 and then an additional 50 microliters of the blowout volume if you wanted, up to 50 microliters to get the total of 300.
Okay. And does the iSeries replace or phase out the NX and FX, or will the older models still be available And what are the key technology advancement differences between older and newer models? Tell me if you want me to repeat the second part. You have to answer the first part.
Yeah, so the NX and FX are still within our product portfolio. I think the one slide there at the end showed where we started with the 4000, went to the NX in terms of medium throughput, and then of course the i5 to the FX to the i7 and up into more of our extensions or integrated systems. So the full product portfolio is still available. They provide different niches, and because we have a number of different applications already verified or demonstrated on the NXFX, is still a reason why someone might want to continue to use an NX or FX or purchase an NXFX. Some of the biggest differences in terms of why you might want to go to the i5, i7, again, the big issue would be the deck capacity itself, which is twice that of the individual platforms like an NX or FX. Those are big. Certainly the camera feature, which we call deck observation, is something that's not available on the NXFX. On the multi-channel side, we no longer use a tip loader as the way to load tips. We actually do a force loading, so the tip loader goes away. And also because the tip loader goes away, the tip loader actually ran on compressed air. So we no longer have any need for compressed air on the system, certainly based on the i5 and i7 itself. Now, there may be a need based on some other peripheral devices that someone might want to integrate on the deck, but certainly for the operation of the i5 and i7, there's no need any longer for compressed air.
Can sterility be maintained?
So on the i5, i7 in the enclosed version, we wouldn't go so far as to say that we maintain sterility, but we would, we do say that we can put HEPA filters up on top. So the enclosed version is, in a sense, at the basic level, it's really a dust cover, if you will, or protection from the external environment of the laboratory or the HVAC systems within the laboratory. To add on to that, if you wanted to put sterile air onto the surface of your work surface, that's where we put the HEPA filters. So the HEPA filters, of course, would be producing up to sterile air, let's say like an ISO 5 type air quality level. But then, what's on the inside and how clean the system is maintained in terms of the inside of the instrument would be of question. So that would really be up to the individual laboratories as how clean they keep the work surface itself. But providing clean air or sterile air in terms of ISO 5 certification, the answer would be yes.
Can I use selective tip pipetting with the multi-channel heads of the iSeries?
You can. So with the i5, i7 platforms now, we actually include selective tip pipetting within the Biomek software. Today it's available, but it's actually a plug-in that we would sell as a separate software package. But on the i5, i7, it's a part of the new Biomek software where you can do columns, rows, single pipette, quadrants, really any configuration where you're coming in from the external perimeter of a tip box. You can also, however, build up an empty tip box, if you will, into any configuration you want. For example, if you're doing a serial dilution across a plate, but you're doing it in duplicate, you would simply just grab a column or a row, depending on what format or positioning your plate is, and just put in 2 columns into an empty tip box, and then pick that up again with the multi-channel head and do your serial dilution in parallel across the plate.
Do I need to make changes to my limbs to work with the Biomek?
No, generally not. The Biomek software is able to import comma-separated values files in a number of different configurations. In fact, we reached out to our users with an independent survey, and the response was that 73% of Biomek users never have to consult with IT in order to pull data reports. So there's a lot of flexibility in bringing information into your Biomek to drive something like hit picking or like normalization. And again, on the output, in order to track the work that's been done, again, that's something that can be incorporated into LIMS. The Dart Data Manager makes this even stronger, allowing us to have direct connections into databases.
Okay, thanks. Okay, we have time for one last question. So if we didn't get to yours, we will follow up with you via email. Can I use input files to do hit picking? Oh, you know what? Sorry, let's skip that. Let's run to this one. Is there a way to add a UV light? This relates to the concept of sterility of the deck.
So another good question. We are always very cautious, particularly in our quality and regulatory environment here at Beckman Coulter. We've done a number of studies on the UV light. Can it be done? Yes. Have we done it? No. And the reason why is the UV light is, for those of you who know on sterilization-wise, typically UV lights are mounted up on top, and so then you get a problem with shadowing of the deck surface itself, so you don't really get sterilization on the deck, although you would think so because you've got a UV light, right? So that's one issue. Also, UV light is not a very good sterilizing technique unless it's very close to the work surface itself. So again, having a light 3 feet, 4 feet away from the work surface, which is what you want to sterilize, typically is not very efficient. Some byproducts of putting UV lights into systems, and I've seen a number of them out there in laboratories, whether they're on full enclosures, for example, and whether that's on Biomek or other automated liquid handlers platforms, is the acrylic panels on the side usually end up crazing over time. And also the UV radiation is very harsh on anything like tubing lines or cabling of any sort. It does discolorization on skins, the panels, for example, on your devices. So it can be very destructive. So again, it's just a word of caution to keep in mind. I know there's some, I believe there's some regulations actually at various facilities. I think NIH is one of them. I stand corrected on that. But where they actually do not allow UV lights even in laminar flow hoods because of the precautions that they want to have from safety to the user.
Okay, we're going to jump back to this one. Can I use input files to do hit picking?
Yes, of course. There's a number of ways to bring information in. That can be done through a file. Again, the Dart Data Manager would allow that to come in from a history, even if that plate was used on a different method where that information was attached to the plate. Okay,
and I do see more questions coming in, so again, sorry we have to wrap up, but the speakers will follow up with you after the event. I would like to once again thank Raj Kapadia, Bob Lund, and Tim Sherrill for their presentations. Please remember this webinar is the first of a 3-part series. The second and third webinars, which are application-focused, are scheduled for Tuesday, April 18th and Thursday, April 20th. Registration for both webinars is open on the LabRoots website. I'd also like to thank our sponsor, Beckman Coulter Life Sciences, for making it possible to bring this presentation to you. Today's webcast will be available for on-demand viewing through September 22nd, 2017. You'll receive an email from us alerting you when it's available on demand and posted on labroots.com. You're welcome to forward this announcement to any colleagues who weren't able to join in today. Thanks for logging on and participating in today's broadcast. We'll see you next time.